Today is 5.4. So I think there are six kind of versions of these questions. And if you are a puzzle person, you're going to love these. If you're not a puzzle person, this is kind of difficult. If you like to know, okay, this problem, I follow this series of steps, this might be a little bit difficult for you. If you're kind of a shoot from the hip guy, figure it out, or gal, then you will like this. So, first we have to identify the reference angle. So, in every quadrant, the reference angle is the rotation needed to get from what's called the terminal angle, wherever your line stops, and the x-axis. So if I had, let's do this in degrees first. If I had a 15-degree angle, that's going to land in quadrant 1. So this line is called the terminal side. That's where it stops. The reference angle is the angle between the x-axis and the terminal side. So it turns out that's the reference angle, which happens to be 15 degrees. So in quadrant 1, your reference angle always is right there. Now you might say, duh, why do we care? Well, what if I had a 370 degree angle? Where would that land? It's going to go all the way around and 10 degrees more. So for a 370 degree angle, what is the reference angle? It would be 10. So the reference angle is 10. The reference angle is the one we use to build our triangles, and reference angles are always 90 degrees or less. Fewer. Oh man, I just committed the unpardonable. I said I mixed up my lesson more. Okay, so what about a 160 degree angle? Where is that? It's in quadrant 2, so right there. The reference angle would be this one. How big would that angle be? 20 degrees. It's the angle between the terminal side and the x-axis. So if I had 199 degrees, where would that be? That's going to be in quadrant 3, right here, and the reference angle would be 19. And then if I had 330 degrees, that's going to be in quadrant 4. The reference angle would be this one, which would be 30 degrees. Okay? And in my opinion, it's actually a little bit easier to do reference angles in radians than it is in degrees, because the numbers are smaller. So, where is negative 7 pi over 9? It's not going to be on the unit circle. It's not one of the special ones. So, this is 0 or 2 pi, and this is pi. It's got to be in 3. We're going backwards, and we're going to do 7/9 of pi. So we don't quite finish the bottom half. So we go this way, and we stop at 7 over 9. How big is the reference angle? How many more ninths is it going to take to get to pi? 2. And reference angles are always positive. All right? So even if your rotation is negative, the reference angle is always positive. So for this angle, our reference angle would be 2 pi over 9. Okay? What if I had 4 pi over 3? What quadrant does that land in? 3. How come? It's a full pi and a third of a pi. So what would the reference angle be? 1 pi over 3, or just pi thirds. No. That's one of the nice things about radians is a lot of these you can just figure out in your head. Jensen's he's taking the lazy route. Okay. What about 5 pi over 3? 1/3. What quadrant does that land in? So how far is that? 3/3. That's 6/3. So 5/3 would be right there. How big is this angle? 1/3. And again, the reference angle is always positive. Okay. What about 14 pi over, let's say, 23? Which quadrant does that land in? Two. How far is it to there? This is 23 pi over 23, and this is 0. So is 14 closer to 23 or closer to 0? So it's going to be quadrant 2. Now, how big is that angle? Well, how many more 23rds do I need to go from 14 to 23? 9. So the reference angle in that case is 9 pi over 23. Do you want to see any more of those? Okay. So, determine the quadrant in which the terminal side of theta lies. So we have a negative cotangent value and a positive cosine value. So sine is O over H, cosine is A over H, tangent is O over A, and then the cosecant is H over O, and then the secant is H, let's fix that, is H over A, and the cotangent is A over O. But in the unit circle, the H is always 1, right? So when we do the unit circle like this, how far is it from here to here? 1. So all of our H's actually go away. Well, all of the H's on the sine and cosine go away. And in these triangles, we figured out that cosine is always the x value, and sine is always the y value, which means that these are just the opposite, and then this is just like that. So, in which quadrants would sine be positive? Where is the y-axis positive? 1 and 2. Where is the x-axis positive? 1 and 4. Where would the tangent be positive? 1 and 3. So, we made this really nice mnemonic. I hope you didn't write all that down. And we say this: all suckers take calculus. It's actually all students take calculus, but only calculus students think that's any funny. So, what does this mean? In quadrant 1, all of the trig functions are positive. In quadrant 2, the sine is positive. In 3, the tangent is positive. In 4, the cosine is positive. Now, going along with that, of course, the cosecant, the cotangent, and the secant would follow. But that's how we remember it. All suckers take calculus. And really, that's the mnemonic that the whole world uses. I don't know why. I guess maybe in a different language it doesn't work. So, we look here. If the cotangent is negative and the cosine is positive, which quadrant are we in? So this is the list of positives. So everything's positive, the sine's positive, the tangent's positive, and the cosine's positive. So which quadrant has a negative cotangent and a positive cosine? Would have to be 4. Okay? B, which one has a positive secant and a positive sine? Secant matches up with which one? Cosine. So is there one where both the sine and the cosine are positive? Quadrant 1. That would be it. Okay, let's look at another one of those. Nope. Oh, must be number 8. Okay. Sine is negative and cosine is negative. Which one has both the sine and the cosine negative? Would have to be in 3. Because only the tangent and the cotangent are positive in 3. And the next one, sine is negative and the tangent is positive. That would also be 3. Okay? Do those make sense? And if you take calculus, you're a sucker. Actually, calculus was my favorite class in high school. It was awesome. All right. So, we have a terminal side, and the point for that terminal side is 3, -2. How big are the cosine, the cosecant, and the tangent of that angle? So where is the point 3, -2? It's in quadrant 4. So we go right 3, down 2, right here. And we draw our triangle, and our reference angle has to hit the x-axis. Do I know any of the side lengths of this triangle? 3 and -2. Can I find h? Pythagorean theorem. So 3 squared plus 2 squared. Why did I not write the negative? It's going to go away. And h is always positive. Okay? For all of these triangles, h is always positive. So I get 9 plus 4 equals 13. What do I do with that 13? Take the square root. So this becomes root 13. So here is my angle. That is my angle theta. But I'm dealing with this reference angle to build the triangle. What is the cosine of that triangle? So cosine is a over h. So the a side is 3 over root 13, but can't leave a root in the denominator. So we get 3 root 13 over 13. What? I can't tell who's talking behind masks. Okay, so that one's a pretty easy type. Let's look at number 4. Okay. It tells us we are in quadrant 3. So I draw a reference triangle in quadrant 3. The cosine is -5 over 13. what are the values of the cosecant and the tangent of that same triangle? Well, the cosine is a over h. So how do I know that it's negative 5, 13 and not 5, negative 13? H is always positive, and we're in quadrant 3, so the x value has to be negative. So I need to find this value. So a squared plus 5 squared equals 13 squared. A squared plus 25 equals 169. Subtract 25. A is 144. A squared. Square root, and a is not 12. Negative 12. Right? Technically, we should write plus or minus. But in this case, it has to be minus because we're in quadrant 3 and the y value is negative. So we write a negative 12 here. What is the cosecant of this? So cosecant is the sign upside down. So cosecant would be 13 over negative 12. You guys get that? And the tangent is just going to be 12/5. All right? We're in quadrant 4. Tangent is negative 4/3. So tangent is O divided by A. Which one of those is going to be negative? The O value, the Y value. So negative 4 and 3. And what's the hypotenuse going to be? 5. That's our favorite triangle, 3, 4, 5. And the cosine is going to be 3 over 5. Doing that. And the cosecant is going to be 5 over negative 4. Okay? And hopefully in the next problem let's see if they do it. Secant, okay, that'll work. Okay. The secant is 6/5. Which quadrant are we in? It could be, so secant matches up with cosine. So if we have all suckers take calculus, which two quadrants would the secant be positive in? 1 and 4. So which one is it? It's 4 because they gave us a little bit more information and said, and the tangent is negative. So we build our reference triangle, and we have a 6 and a 5, and then we figure out what that one is. Okay, but what about this? What if I had the tangent of theta is 3/4, and we're in quadrant 2. What is the value of the sine? Draw my reference triangle. How do I label it? So the sine of theta would be, is nobody going to correct me? These have to be negative, but it didn't show up in the original problem. That's because tangent is positive in quadrant 2 because the x negative and the y negative cancel. Do we care? Yes, because the sine has to be negative. So the signs do matter even when they cancel on a tangent problem. All right, you guys look so excited. Get to work.